Welcome to Prospective Doctors MCAT Podcast, brought to you by Med School Coach. Each week, Sam breaks down the highest yield MCAT topics so you can score as high as possible on test day.
Hello and welcome to a bonus episode of Prospective Doctors MCAT Basics. Today, I'm going to go over the common ions that you need to know for the MCAT, as well as the solubility rules. And I decided to make this a bonus episode because, number one, it's like only a teeny bit of material. And number two, I think this is almost like a verbal note cards podcast. Because what I did is I started the actual material at the 2-minute mark. And in that way, if you want to listen to this over and over, you can just skip forward through this introduction in order to get to the good stuff. And the common polyatomic ions and the solubility rules are important to know for the MCAT, especially for the Chem Phys section. So you might see solubility problems or acid-base problems in which you're given the name of some complex ion or some polyatomic ion, something like calcium phosphate. And maybe it asks you to calculate the solubility of it or wants you to balance some chemical equation or something where you need to be able to know the charge of each of these individual ions in order to determine the overall formula of calcium phosphate. And so the overall formula there is going to be Ca3PO4 2. So again, knowing these charges is going to be very important. Then with the solubility rules, you might see some sort of selective precipitation question where you are given two salts that are soluble, they're mixed together, and then the question tells you that one of these salts precipitates and forms a solid, then asks you to recognize the chemical formula of whatever it is that precipitated. And in that case, you're going to have to know which salts are insoluble. So let's first start with the common ions to know. So what I'm going to do here is list the names, charges, and formulas. Ammonium, NH4 plus, not to be confused with ammonia, which is just NH3 with a neutral charge. Hydroxide, OH minus. Nitrate, NO3 minus. Nitrite, NO2 minus. And what I want to And I quickly want to mention that the important thing here to memorize is the -1 charge. You don't really have to. And I want to mention here that the important thing to memorize is the -1 charge, not necessarily the difference between nitrate and nitrite. You can think though that nitrate is NO3. It has an extra oxygen, and therefore it ate the extra oxygen because of that ATE ending. That's how I think about it. Sulfate is SO4 2 minus. Sulfite is SO3 2 minus. Phosphate is PO4 3 minus. Phosphite is PO3 3 minus. Chlorate is ClO3 minus. Chlorite is ClO2 minus. Perchlorate is ClO4 minus. And hypochlorite is ClO minus. And important to note again, the charges are what's important to know. The prefixes per and hypo can be added on to any of these polyatomic ions. And per essentially just means that you're adding on an extra oxygen to chlorate, hence the perchlorate, whereas hypo is you're taking an oxygen away from chlorite, hence the hypochlorite. So that's the easiest way for me to remember this, is just that this prefix means you take it a step further. So chlorate has one more oxygen than chlorite, but then when I add that initial prefix, I'm just saying that I'm giving it another oxygen and making it even bigger. So it's kind of how I memorize that. But again, charges are what's important. Carbonate is CO3 2 minus. Carbonite is CO2 2 minus. And bicarbonate is HCO3 minus. Permanganate is MnO4 minus. Chromate is Cr4 2 minus. Dichromate is Cr2O7 2 minus. Thiosulfate is S2O3 2 minus. Cyanide is Cn minus. Peroxide is O2 2 minus. Acetate is C2H3O2 minus. And there are two last things I want to mention. The first here is that you can have a hydrogen prefix. So I could have hydrogen phosphate, which would be HPO4 2-, or you can have a dihydrogen prefix, and in the case of dihydrogen phosphate, this would be H2PO4-. So essentially, each time you add a hydrogen, this cancels out one unit of charge. In other words, hydrogen is basically Twitter. It just cancels negative stuff that it doesn't like.
Thanks for checking out the Prospective Doctor MCAT Basics podcast. Sam's doing a killer job taking you through the most important MCAT topics, but what if you need a little extra help? How does a 5, 10, or even 15-point increase in your score sound? Imagine how your chances at admission could increase. Med School Coach's MCAT tutoring can get you there. With the most rigorous selection process of any tutoring company, we see amazing results. We deconstruct each student, find a plan that is going to work, and help execute it. That's why our students add an average 12 points to their score. Completely physician-run and operated, and focusing on nothing but medicine. It's no wonder over 10,000 past students have trusted Med School Coach to get them through the MCAT and into medical school. Check out medschoolcoach.com today and mention code PODCAST for 5% off.
Anytime you have an IDE ending, so something like chloride versus chlorite versus chlorate, that can be confusing. An IDE ending just signifies a monoatomic anion of some element. So take chloride is Cl-, chlorate is ClO3-, chlorite is ClO2-. So I kind of think of chloride, the IDE ending, as being like the simplest case. And then the last thing I want to mention is don't memorize the potential charges of transition metals. You'll be given Roman numerals to describe these. So you'll have something like iron 2 oxide to describe that you have an iron that is a positive 2 charge. And so it's important to recognize that the transition metals can have a bunch of different charges. So don't even think about trying to memorize, what the range of charges this certain transition metal will have. You'll be given that. On to the next topic to discuss, which are the solubility rules. And there's 7 solubility rules that I want to talk about. And when I'm talking about these solubility rules, I'm talking about their solubility in terms of solubility in water. So just keep that in mind. And also keep in mind that when I'm talking about these individual ions, that they are actually going to be in complex with another counter ion to make some solids. So when I say acetates are generally soluble, I'm talking about acetate in complex with a counter ion, and that counter ion can really be anything. So it could be, of course, it's got to be the opposite charge, but it could be something like sodium acetate. So just keep that in mind. The first rule is that acetate salts are generally soluble, and again, acetate has a -1 charge. The second rule is that nitrate salts are generally soluble, and nitrate has the formula NO3-. Rule number 3 is that alkali or group 1A salts are typically soluble, and these are things like sodium, lithium, potassium. The fourth rule is that ammonium salts are soluble, and ammonium again is NH4+. The fifth rule is that the halide salts are generally soluble, and the halides again are the furthest column over on the periodic table, things like chloride, bromide, iodide. And the exception to this rule is in the case of silver or lead, which are Ag and Pb on the periodic table. So for example, a salt like silver chloride would go against the rule that all chloride salts are soluble because silver chloride is insoluble. And that brings me to the sixth rule, which is that silver and lead are exceptions to a lot of the solubility rules. In other words, they produce compounds that are highly insoluble. So for instance, in Rule 1, I mentioned that acetates are generally soluble. Well, silver acetate is an exception to this rule because it is insoluble or very hardly soluble. So just keep in mind if you see silver or you see lead, which again is Ag and Pb, that salt probably isn't soluble. And then the seventh and final rule is that carbonates, chromates, and phosphates tend to be insoluble. So those are the rules that I memorized on the MCAT. I didn't see anything that went beyond those rules, or I didn't feel like I was missing any questions because I didn't have enough info on solubility of salts. If you see something come up on the MCAT, obviously throw it down on a note card if it doesn't follow one of these rules. But I hope this helps.
Thanks for listening to Prospective Doctor's MCAT podcast. If you're a pre-med, you'll want to check out prospectivedoctor.com for tons of free tools, articles, and more podcasts that cover your pre-med life. And if you need help on the MCAT or getting into med school, check out medschoolcoach.com for the experts.